Hi everyone, how are you all? Welcome to AWS Certified Practitioner course by Dataflare. In this lesson, we are going to talk about traditional IT systems and classical data centers. So let's get started. In this lesson, we are going to cover journey to the cloud. Let's see how we reach to cloud computing from traditional IT systems to cloud services. We'll talk about traditional IT systems and its characteristics. We'll talk about the different challenges in traditional IT. We'll talk about the classic data center, abbreviated as CDC. So let's get started. Let's see the journey to the cloud. And you can just see this is the whole transition from classic data center to cloud services. Here you can just see that this is classic data center, which another way we call it as traditional IT system, on which we rely heavily on the servers, data storage systems, networks, other equipments. And then we added virtualization technology here after this CDC. It become VDC, virtualized data centers. We'll talk more about virtualization in upcoming lessons. And then you can just see here, we move to the cloud services. When compute resources from VDC are coupled in the form of services which is available to organizations and individuals, then it become cloud services like AWS, Amazon Web Services. This is the whole journey to the cloud. We started from traditional IT system, that is classic data centers. We added virtualization technology just to improvise the utilization of hardware and other resources. And then when it is bundled in the form of the services, then it become cloud computing. We'll talk more about it just to give you a glimpse of how we started and how we come to the cloud computing. All right. Let's talk about the traditional IT system and its characteristics. When we talk about traditional IT systems, just imagine we have servers, compute servers, database servers, storage systems, networking equipments, and here are some of the characteristics of traditional IT system. Let's talk about them one by one. So first is infrastructure. As I have given you an idea that in traditional IT system, we rely heavily on servers. So we have all servers. It might be compute server, which is used for processing purposes. There might be a database server, which is acting as a backend. And it might be a storage system where we store files, where we store data, on the top of which we can have operating system and we can have the applications on that operating system, which is hosting the different applications, different business, different operations. So infrastructure in traditional IT systems heavily rely on those hardware servers. Then we talk about the cost model. This is very important aspect when you understand the traditional IT system. Because when you talk about traditional IT systems, you have to heavily invest on servers, equipments, place, power, cooling, security mechanisms. You need to buy everything that you want, right? So cost model is CAPEX, capital expenditure. Along with that, there are a lot of operational expenses as well when you are running on-premises traditional IT systems. Then when we talk about the scalability, it's also a big issue in traditional IT systems. Just think about it. Let's say right now I have 200 GB capacity server and I know in future I might need 500 capacity server. So in that case, there are a lot of limitations of traditional IT systems because when you have the whole infrastructure, it is not necessary that it will support 500 GB capacity server. It's not possible. So, the key takeaway from this point is when you talk about traditional IT systems, scalability is an issue. You can scale the whole system up to certain point, not after that. That means you cannot actually think about very big business, very big organization, lot of different customers and a big application hosted on the traditional IT systems. Not possible, right? Then think about the accessibility. Oftenly, the traditional IT systems are limited to local networks. That means the applications, data, and other resources are accessible within a local network. Think about a global client which is trying to access your application from outside that local. So you can connect your whole system to internet, but there are certain limitations in terms of accessibility. You can also think about the accessibility in terms of the platform, right? When you talk about traditional IT systems, there are limited platforms from which you can access those applications and data. Then think about security. It is also a big concern because your whole data, your whole application is within a single traditional IT system. It is on premises. So whenever somebody want to access it from outside your local network, then security might be a big concern. You have to set up a firewall. You have to check the network. You have to check the incoming traffic from outside internet to your on-premises data center. Then disaster recovery and backup. It's also a big concern for business. They want their data secure. They want that if in case any outage happens, like any downtime happen, something like it may be network failure, it might be natural disaster, it may be anything. So in case of any problem, right, I should not lose my data. So when you talk about traditional IT systems, there are very limited options that we have in terms of disaster recovery and backup. Just think about a 200 capacity server in your traditional IT system. And let's say you think about a backup server. So you have to parallelly set up another server of the same capacity in which the whole data of your main server is replicated or backed up so that when any kind of outage occur, you can recover it back to the main server. So it's also a very, very important aspect, and it's a kind of challenge in traditional IT system to have such disaster recovery and backup solutions. Okay. And I think now you might be getting the idea that why I am discussing all these things, because the shortcomings of the traditional IT systems become advantages of the cloud computing. Yeah. So let's see it. In terms of specific challenges in traditional IT system, let's see some points and let's try to understand it in terms of business. All right. So when you talk about the globalization, what exactly it means? It means that when you talk about global clients, let's say you have some global clients, you have some customers all over the world, they want to access your application, your data, everything. Then it is not possible while working with a traditional IT system to go global in minutes. It might take a lot of time to set up all those things for global clients. It's not possible in one go. So globalization is a problem. And one more thing that you can also think about globalization is like serving the global customers for 24/7 cross 365 days, right? Think about storage growth. You might be thinking about here, storage growth is nothing but the data that we are producing every second. We are producing huge amount of data. It may be anything in terms of feeds, in terms of social network, posts, in terms of images, in terms of generative AI. We are generating a lot of data. Yeah. So the point is, the traditional IT systems are not planned in such a way that it can accommodate the growing business. Because when the business grows, data also expands. If your system is incapable to handle such growth, then that might be a challenge in future. So that is a problem in traditional IT systems. Then we talk about the cost of ownership. When we talk about cost of ownership, it is all capex. I have already discussed about that. It's all capital expenditure. You have to spend a lot of money upfront in advance before you actually doing some operations. So this is heavy cost which is involved in traditional IT system. It's a challenge. Think about a startup which do not have such money to spend a lot of on the servers, networking equipments, databases, nothing. Licensing cost, we don't have such money. then in such cases, the system may fail. Yeah. Think about the aging data centers. When we talk about aging data centers, it's the idea when we want to store data for very long period of time, let's say 5 years or maybe 10 years. We think about like this document or this data might be useful even after 10 years. So aging data center is a problem with traditional IT system because the hardware equipment that we are using in our traditional IT system has some age, which requires some upgradations, which requires some replacements, then it's a problem, it's a challenge. You have to again buy new servers, you have to set up the whole thing again, you have to start from scratch. It's a problem. Think about application explosion. Just think about new technology, new applications coming up. They require new kind of platform, new kind of capacity in terms of compute, in terms of storage, in terms of networking. Then for traditional IT system, it is very challenging to support new generation applications which require very high amount of compute, storage, maybe networking. So traditional IT systems cannot accommodate next generation application. They are not planned in that way that it can accommodate new applications coming in future. Then the last but not the least is acquisitions. When a big company acquires a small company, then they have to think about what kind of platform that the small company is working on. Let's say X company is acquiring Y company. So for X company, it is very challenging to acquire the different platform of Y. But just think about if Y is running on the same platform which usually X is running, then it will be easy for X to acquire Y. So acquisition is also a big concern when you talk about the traditional IT systems. I hope it is understood. Now let's specifically talk about classic data centers. Although we are talking about the traditional IT systems. Here when I talk about the classic data center, they are very large capacity facilities where we actually process large amount of data. That is why it is called as data center. So when you talk about the classic data center, it is older version of data centers. The older version of the facilities. Right now also, some of the companies have followed the same procedure, but almost all the organization want to move to cloud because of its advantages that we will see in upcoming lessons. So when you talk about the CDC, as it is abbreviated, it is a facility that provides IT resources to process data. What are different components? Components are compute. Compute means server capacity, computing capacity. Just like processors that we have in our laptops, right? Then we talk about the storage. We talk about the network, applications and DBMS to support backend applications. So here, the core of classic data center is very similar to the normal systems that we see, but the capacity is huge. It can actually accommodate very large amount of data. But there were some shortcomings of this CDC. Lack of resource utilization was the biggest concern here in classical data centers. That means whatever the resources that we are using in terms of compute, storage, network, application, it can be anything, was not fully utilized, because of the hard provisioning. We'll talk about it in upcoming lessons. That's it for this video. I will see you in the next video, guys. Thank you. Hello everyone, how are you all? Welcome to AWS Certified Practitioner course by DataFlare. Welcome to this lesson and let's try and understand what we are going to do in this lesson. We are going to talk about what is cloud computing. So let's see what topics that we are covering in this particular lesson. We will talk about what is cloud computing exactly. We'll talk about different characteristics of cloud computing. We'll talk about cloud versus on-premises. We'll compare the traditional IT system, which is generally on-premises, and cloud. We'll talk about the different advantages and applications of cloud computing. So let's get started. Let's talk about what is exactly cloud computing. So when I talk about the cloud computing, Cloud computing is on-demand delivery of compute power, database storage, applications and other IT resources through a cloud service provider or a platform via the internet with pay-as-you-go pricing. There are a lot of points that you should pay attention to. Here, let's talk about the first one, that is on-demand delivery. Let's talk about on-demand delivery. What do you mean by on-demand? On-demand means whenever you have some demand, whenever you have some requirement. Let's see here in terms of compute resources. Let's say you are running a stock market application and you know that, right? The stock market will run from 9:30 a.m. to 3:30 p.m. So you want the compute resources, you want the whole infrastructure in that given time period only. That means you just want to pay for that time interval. You don't have to pay for the whole day, right? You just have to pay for that 8 hours or maybe 7 hours. Just think about the other resources like compute power. You need compute capacity, you need database storage, you need applications and you need other resources, but on demand. That means whenever you need. Let's take one more example. Let's say you are in a university setup and you know that there are servers in university which will respond in terms of the results of the students, in terms of maybe registration, something like this. So just think about it, the servers which are running will have lot of requests when the university have declared the results. That means at that point of time, they need more capacity, they need more servers. So they can actually have it from cloud service provider on demand. I hope now you're getting the idea about on demand. And these are all resources which can be hired. And through the cloud service platform, right? Provider, platform, one of the same things, like alternative term that is being used in market. So when you talk about cloud service platform, it's a platform like AWS, Azure, Google cloud provider. So here they will provide the resources in terms of services, right? Via internet, that means from anywhere where you have the internet access, you can access those resources. And here is the main highlight of this definition, pay-as-you-go pricing. So you can just see that you are getting the IT resources on demand. That means whenever you need it, you get it. So why you pay for the all time? It's not required, right? That is why cloud gives you pay-as-you-go pricing. When you exceed your limits, when you scale up, right, then you have to pay for that resources. And when you scale down, let's say now the result time is over, now there is no much request on the university servers, so they can scale down, right? We'll talk about scaling up and scaling down in upcoming slides, but the capacity that is being enhanced, that is being scaled up, you just have to pay for that. This is the definition of cloud. Let's talk about different characteristics of cloud computing, which will make you more clear about cloud computing. Let's go one by one. Let's talk about on-demand self-service. Although we have discussed what is on-demand. So on-demand is whenever you need it, whenever business need it, whenever the capacity is required. What is self-service? Self-service means whenever you're using cloud computing, you don't have to request for something, you don't have to wait for that resource to be allocated to you, nothing like this. It's like self-service. With some clicks in user-friendly interface, you can get that resources and you can release it whenever you do not need it. I will show you all these things in the hands-on part. Think about the next, rapid elasticity. It's very, very important. When you talk about rapid elasticity, it directly indicates the scale up and scale down. So like whenever you need it, you can scale up. Like for an example, your application is running on 5 servers and at a point you need 10. So you can enhance that capacity from 5 to 10, that is scaling up. And whenever you don't need them, like your operations are done, you have already served your customers, now you don't need that extended capacity, then you can scale down. So you can come back to your original capacity, that is 5 servers. All right. Then think about the measured services. Measured services are the way to measure that how much capacity that you have used from that resource. Just think about electricity at your home. So whatever you consume, you just have to pay for that, right? So metered or measured services, okay? Resource pooling. It indicates the infinitely scalable capacity of cloud computing. When you talk about cloud computing, yes, logically infinite capacity, right? So think about resource pooling here in terms of storage, in terms of compute capacity, in terms of networking, it may be anything. Just think about any IT resource, we have infinite capacity, right? That is the clear message from cloud computing. Then last, broad network access. When you talk about broad network access, you can clearly understand that the resources provided by cloud service provider can be accessed from anywhere. It may be your mobile phone, it may be your laptop, it may be any device which supports the internet connectivity can actually leverage the resources provided by cloud computing. And it is global, right? It is on demand on internet. That means from anywhere. Let's say for an example, you are here in India and you have actually got the infrastructure for your application in Indian region, let's say that, and you want to access it from US region, or maybe your clients are in US. So with the help of broad network access, the clients or the customers all over the globe can access your infrastructure from anywhere, from any time, with any capacity. That is the clear message from all these characteristics of cloud computing provided by NIST. Now, here is a very interesting comparison between when you set up your infrastructure in cloud or when you do it on premises. What's the difference in terms of cost, in terms of performance, in terms of scalability? What is the difference? So let's go through these pointers. This will actually give you the clear idea why we are moving towards cloud computing. All right. So first thing that we talk about is no upfront investment in cloud. Of course, when you hire resources from cloud, you don't have to upfront invest heavy amount in servers, in capacity, in hardware, nothing. You just have to hire for that service, good to go. Yeah. And then when you talk about the on-premises, when you are managing your own infrastructure in your company, in your premises, then large initial purchase, very heavy. I want to mention one thing here. When you talk about all in cloud, it's actually OPEX model, operational expenditure. You just have to worry about the operational expenditure. Forget about the capital expenditure. But when you talk about the on-premises, or as we have discussed, the classic data centers, then you have to do by your own. Yeah. So when you talk about on-premises, it is capex, that is capital expenditure, plus operational expenditure that you have to spend. Yeah, it's a very heavy cost, right? And you can just see low ongoing cost, again low operational cost, because of shareability, because of a lot of different options that we have of scalability, like scale up, scale down, wherever we need it. It's all on demand. Then when you talk about on-premise, it's laborious, patches, upgrade cycles. We have to upgrade our hardware. We have to upgrade our licenses. Lot of requirements. Then you can just see focus on innovation. Forget about the infrastructure. The cloud computing or cloud service provider will handle all your needs. And then here, system administration. Heavy system administration and monitoring is required in terms of monitoring the capacity, monitoring the performance, security concerns. There are a lot of issues that need to be administered. Then here, flexible capacity. Very important point that you should capture here. Flexible capacity. As I said, right, whenever I need more servers, I can get it. When I don't need it, I can release them. So it's like flexible, right? But when you talk about on-premises, fixed capacity. You just have limited capacity through which you can host your customers, your consumers, right? Then speed and agility, as I told you, it's very fast. You can go global in minutes, you can scale up, you can scale down. But when you talk about on-premises, long procurement cycles and setup need to be done before doing anything. Think about scaling up. Let's say you have 200 GB capacity. Now you want 500 GB capacity. You have to go through long procurement cycle. You have to buy new servers. Yeah, then only you have to set up, you have to integrate again with the upcoming system, and you have to do everything from scratch. Then global reach on demand, as I told you, it is globally accessible. Yeah, but here limited geographic region that is supported by on-premises. Definitely now you're getting the idea why everyone want to host your applications, the infrastructure on cloud. Why they want, right? So I hope now you're getting those advantages. Now, these advantages, let's point it out, right? Although we have discussed a lot of advantages, but let's have a quick recap on those things so that the things are clear, and then we can move forward. Yeah. So the first thing that we talk about is reduced IT cost. That means avoid the upfront capital expenditure, as I have already told you. We don't have to worry about the infrastructure cost. We can use it because it's already there in CSP, right? Then business agility support. Provide the ability to add new resources very quickly, just like this. Then flexible scaling. Scales up and down easily and instantly based on your business needs, based on your demand. Everything is so flexible, right? High availability, as the accessibility is very high, broad network access. Then you can just see that highly available applications, data, resources, everything, right? It will ensure that applications are available all the time. The data is available all the time, depending upon the policy and priority that you have configured. Yeah. Less energy consumption, of course, right? When you are not actually handling your own data center, you are relying on cloud service provider to host your application, host your data. It's all less energy that you are consuming, right? Because you are relying on the CSP. You are not doing everything by your own. Now, the question arises, what exactly we can do with the cloud computing? We have seen a lot of advantages, but exactly what we do with the cloud computing? Let me just tell you, we can do a lot of things. Some of them are listed here. We can host the applications, we can backup and storage, we can use cloud computing resources for backup and storage purposes. We can use, just think about the Google Cloud Service in your mind when you talk about backup and storage. Yeah. Content delivery. When you talk about these services like YouTube, Netflix, they deliver content on demand, right? Let's say I want to watch a movie, so I will go to Netflix and watch a movie. So how the content is delivered, right? It should be without any lag, without any delay. So there are different services available in cloud which supports the content delivery. We'll talk about them in upcoming lessons. Then the websites. We can host websites. We can do enterprise IT. When you talk about enterprise IT, it's very large scale softwares which are used to handle a very big, large enterprise. Think about any manufacturing industry, think about banking domain. You will think about the very large enterprises which is handling their data, applications, and doing everything day-to-day operations. Yeah. So they need high precision, they need high capacity. Yeah. So we can rely on cloud computing for such large scale enterprise IT solutions. Then databases. We can use the database services from service provider and we can leverage it as a backend. Let's say we have our own service for application hosting, but for the backend, we need the large capacity or maybe on demand capacity. Whenever we need, we can actually go large and we can shrink back, scale up, scale down. So databases can be utilized. But let me just tell you, this is not actually all the applications of cloud computing. Every organization, every enterprise utilize cloud computing in different ways based on their needs, based on their capacity of expenditure, based on their cost planning budgets, based on their requirement, based on their security concerns, compliance concerns. Different organization uses cloud in different way, but these are some of the important applications of cloud computing. That's it, guys. So I have shown you what is the advantages of cloud computing, what are the characteristics of cloud computing. Yeah, so I hope you got these ideas. Thank you for this video. I will see you in the next lesson. Thank you. Hi everyone, welcome to another interesting lesson of AWS Certified Cloud Practitioner course by Dataflare. In this lesson, we are going to talk about the different service models provided by cloud service providers. Let's see what we are going to cover in this particular lesson. This is nothing but service models. We'll talk about platform as a service, we'll talk about software as a service, we'll talk about the different service models provided by the cloud provider. Let's get started. So here are the three different models that are being provided by cloud service provider. What are exactly these service models? Let me just tell you, these are nothing but the categories of the service provided by cloud service providers. So based on the hired resources, different services are categorized into software as a service, platform as a service, and infrastructure as a service. So let's try and understand deeply what exactly these services are and how these are categorized. So let's go to the next slide. So here, the very first thing that we talk about is going to be infrastructure as a service. In short, we call it as IaaS, right? Basically, it provides the virtualized computing platform. So on the top of the hardware resources that we have, like servers, storage system, networking equipments, everything. So there's a baseline physical layer of all these hardwares, on the top of which we have virtualized layer, which make it more utilizable. So here we have the infrastructure as a service. We talk about the platform as a service. Basically, it offers the development and deployment platform with tools that abstract the underlying infrastructure. Yeah. Then lastly, we have software as a service. We talk about the delivery of software applications, via the internet on the basis of subscription, right? All the Google services that we use are all comes under the category of software as a service. We'll go a little bit more in details. So let's see to the next slide, and I think this slide will clear all the concept that we need to understand about these service models. So let's talk about it. And when you talk about these service models, first of all, you need to understand that a basic IT model has got these fundamental resources, like they have network, storage, and compute. So these are the core of any IT system. Then we have on the top of which we have operating system, we have databases, and we can host the applications. So these are general stack of any IT system. Now, based on the resources that you are hiring from cloud, the service models are decided. Let's try and understand that. So when you talk about these resources, compute, storage, and network, what does it mean? That I don't want application, I don't want operating system, I have my own. I just need a platform on the top of which I can install my operating system. I can install then my applications and serve my customers. In that case, I'm hiring, you can just see the hired resources. I'm hiring the basic infrastructure from cloud and I am good with that. This kind of service is known as infrastructure as a service, because now you can just connect the dots that I'm hiring the infrastructure only. I hope you're getting this idea. And here we have some of the interesting examples on the infrastructure as a service and platform as a service and software as a service. Here, the most important, AWS EC2. We'll talk a lot about EC2 service, Elastic Compute Cloud from AWS. This is nothing but AWS offering which comes under the category of infrastructure as a service. There are other examples also. Rackspace, Google Compute Engine, that is GCE, where we just get the platform. We have everything on the top of which, right? Now, there's a second scenario in which we have platform as a service. What does it exactly mean? I want the basic infrastructure. Along with that, I need a database or operating system as well. I have my applications, but I don't want to spend in operating system licensing cost. Yeah, I don't have that, right? So I want that operating system from service provider. So now you can see this stack is big. Yeah. So when you have this whole stack, that means you just have to come up with your application. You just have to install it. That's it. You have the platform with the basic infrastructure, fundamental building blocks, and the operating system along with a database if required. This kind of category is known as platform as a service, right? Here are some examples. Here, Elastic Beanstalk provided by AWS, Windows Azure mostly used as platform as a service. You can just see that, right? Force.com, right? OpenShift. These are some players in market. And now the last category when you see is software as a service. I don't have anything with me. I just want the basic platform. I just want the operating system on the top of which. I just want applications as well. I will go and use it. That's it. Just think about all the Google services. Do we need to install Google Drive in our system? There's a client, that is a different story, but we don't need to install anything. We just can go to a browser and access the Google Drive and we can go for it, right? So here you can just see the hired resources is complete stack. Can you just see that? So we have the compute, storage, network, basic building blocks. Then we have operating system. Then we have applications on the top of which is directly accessed by the end users. So you can just see the hired resources are the complete stack. Here are some examples. Google Apps, as I told you, right? Salesforce, Dropbox, these are ready to use softwares hosted on cloud infrastructure, which can be directly leveraged and we don't need to do anything. It's ready to be used. So I hope you are getting the difference between infrastructure as a service, platform as a service, and software as a service. And here we have some examples as well. Just to give you a quick recap, infrastructure as a service when we need basic building blocks of infrastructure, that is compute, storage, network. Platform as a service is a category of services when we need basic building blocks along with the operating system. I mean, it's a complete platform on the top of which I can install my own applications. Then here we have the complete stack, that is software as a service, where we actually need everything from cloud. We don't have anything. Based on the business requirement, based on the operations, based on the cost model, right? Different organization, different individuals choose the different options from these service categories provided by a cloud service provider. I hope you are getting this whole idea. So that's it for this lesson. I hope you enjoyed this lesson and understood the concept of service models. Thank you for this lesson. I will see you in the next lesson. Hi everyone, welcome back to another interesting lesson in AWS Certified Cloud Practitioner course by Dataflare. Let's see what we are going to discuss in this lesson. We will discuss the deployment models, how the resources are accessed from the end users. That is what we call the deployment models. Let's talk about it. And by the end of this lesson, you will be able to understand the different deployment models supported by cloud computing. Let's see what are different deployment models supported. So when you talk about deployment model, is exactly refers to how cloud services are made accessible to the end users. Is it privately accessible or is it kind of shared environment from which the individuals or maybe the different organizations are sharing the infrastructure? So we have to think about it based on the requirements, based on the budgets of the organization. Let's come to this. So the very first thing that we talk about is public cloud. We'll think about the private cloud, hybrid cloud, and community cloud. Let's see them one by one in upcoming slides. Let's talk about the first deployment model, that is public cloud. As the name suggests, it is publicly accessible cloud. That means whatever the organizations are, like organization P, enterprise Q, or maybe individual user R, is accessing the same infrastructure provided by the service provider. You can see here is the infrastructure. So like here, when you talk about the public cloud, the cloud resources are available at no or very low cost for the organizations or maybe individual users. Yeah, it may be different services that may be higher, but it is all shared inside a single infrastructure. Don't worry about the security concerns. Securities are maintained up to some extent, but yes, when you have very high level of requirement of the security, maybe compliance, maybe performance requirement, then public cloud is not for you. Why? Because the same infrastructure is actually shared by different organizations, individual users. That means your whole infrastructure is shared. But there are pros and cons of every deployment models. Here, of course, there is a limited capacity, right? Less security and less compliance concerns, but at the same time, it is very low cost. So let's say you have some requirements and you are not really very concerned about the privacy of the data, privacy of your applications, then you can opt for public cloud because it gives you advantage on the cost. Yeah. So here, based on your requirement, you can choose a public model. Of course, there are certain limits. Just think about Google Cloud and Google Drive services specifically. You have 15 GB storage available there, right? And after that, if you want more, then you have to buy for it. So you can just see limited capacity infrastructure is available within the cost limits, within the budgets and everything. So here, the next model that might, different organization may prefer is private cloud. So as the name suggests, private, what does it mean? That it means it is not shared. You will get the full capacity, full performance with privacy. So here, if you just see, there are two different models that we have. Although this on-premises private cloud is not preferred by a lot of companies, this is a better option when you externally host your private cloud. So what's the difference? Just try to understand this. When your cloud infrastructure is exclusively yours, what does it mean? That it is not shared, yeah. And then it is used by a single organization, offering great control and customization needs. Here, if you just see, there are two options available: on-premises private cloud and externally hosted private cloud. When you talk about on-premises private cloud, that means you have your own infrastructure. If you just see, the enterprise P is the part of, or I should say, this infrastructure is part of enterprise P, right? And you can just see that here we have externally hosted cloud. One thing that you should notice here in on-premises cloud, this enterprise P has got whole ownership of this infrastructure. That means enterprise P has to maintain everything inside this infrastructure, whatever it has to do. Right? But when you talk about externally hosted, as the name suggests, it is externally hosted. Yeah, there is a service provider. There is a whole infrastructure of service provider, and one part of the infrastructure is dedicated to enterprise P. What does it mean? That this part of enterprise infrastructure is not shared. It is exclusively for enterprise P. You can just see this, right? That means enterprise P will get the exclusive benefits, exclusive privacy, high performance, no sharing. But as I said, there are always pros and cons of every deployment model. Here, high capacity, high security, high privacy, high compliance, but high cost as well. Yeah. So when you hire a dedicated resource or dedicated part of infrastructure from service provider, definitely it will cost you more as compared to public cloud. So based on your needs, you have to decide whether I should go for a private cloud or a public cloud. But when you are not very sure, or when you have some of the services which you need on private cloud, because you want higher precision, higher performance, security, privacy, but you have some of the applications which may compromise with the security, which may compromise with the performance, then the third model is for you. There is nothing but the combination of private and public cloud. It's called as hybrid cloud. The idea is you leverage the advantages of public cloud, which is low cost, and private cloud for different services, right? Which is actually high performance. So you can just see that here we have private cloud, here we have public cloud, and the approach is actually mixed. Yeah, this can be a good solution for a lot of organization. You can save a lot of money here with this particular type of options. The last one is called as community cloud. This idea is also very interesting. When you talk about the community cloud, so infrastructure, or a part of infrastructure I should say, is being shared with different organizations. Like here we have enterprise P, enterprise Q, enterprise R, which have similar kind of requirements. Just think about universities, or maybe group of institutions, okay, or maybe group of companies, all right, where they need same kind of infrastructure, same kind of scalability, same kind of privacy, compliance, security requirements. Then what they can do is they can share the infrastructure because they are community users. They have similar concerns. So they can share the infrastructure. They can save some cost from this approach. So I hope you are getting the idea that whole idea of these deployment models are actually about the cost. When you talk about private cloud, cost is very high. Public cloud, low cost. When you try the hybrid cloud, cost a little less. You can have the private and public both. And in community, you can have different organizations having the similar requirements, sharing a part of infrastructure. So I hope you are getting the whole idea of these 4 different type of deployment models. So that's it for this lesson, guys. I hope you understood the deployment models, and I will see you in the next lesson for another interesting topic in this series. Thank you so much. See you then. Hi everyone, welcome to another lesson of AWS Certified Cloud Practitioner course by Dataflare. Let's talk about what we are going to cover in this lesson. Now, from this lesson onwards, we'll go specific to one of the pioneer cloud service provider as AWS, Amazon Web Services. So we'll talk about what is AWS here in this lesson. Let's see what topics that we are covering in this particular lesson. We will talk about what exactly is AWS. We'll talk about a little bit of history of AWS. Then we'll talk about the market share of AWS, because there are other cloud service providers as well in the market. So let's see how the AWS is covering the market. Then we'll talk about the key drivers of AWS, which makes it pioneer in the cloud service. So let's talk about them one by one. Let's try and understand what exactly is AWS. So AWS, as abbreviated, Amazon Web Services, is a comprehensive suite of services which is there available on demand, which can be used by any organization or any individual. So here you can see it offers a wide variety of cloud-based services. So if you remember in previous lessons, we understood that when the IT resources are bundled in the form of a service, then it becomes the cloud service provider. Here AWS is one of the service providers of cloud. So here you can just see different varieties of services like compute power. We have different services supporting the compute capacity, then storage, databases, machine learning services, analytical services, networking services, mobile integration, security, and many more services that we have in AWS. Let me just tell you, AWS is a wonderful platform. It supports more than 200 uh, uh, you know services. There are big giants, tech giants like Netflix, Airbnb, NASA, which holds their application, which hosts their data on AWS. So you can see AWS is such a reliable platform which can support very large organizations with very high capacity needs and performance needs. Yeah. We'll talk more about it in details in upcoming slides. Now here we will discuss the specific benefits of AWS platform. Let's talk to the benefits one by one. So first is security. Of course, every organization is worried about the security and privacy concerns of their applications and the data. Just think about it. Here, every application, every organization in a whole, right, always concerned about the security and the privacy of their data. If the third party provider, right, on the top of which they are relying on for their application and data, then just think about it, how crucial the security can be. So here, AWS provides you very strong and robust security mechanisms. It's called as defense in depth. They actually follow very strict security principles in terms of data security, privacy, access control. So AWS, we'll talk about different services in AWS which supports this idea of security. Then we can talk about the reliability. As I've already told you, right, if the platform is not reliable, then no organization will be interested in that platform. Why? Because they want reliability in terms of high availability and disaster recovery. AWS provides you lot of different solutions with the help of which you can ensure that your application and data is available all the time whenever it is needed. And it can also have very robust disaster recovery, backup, replication solutions for the organizations where we have mission critical data. They don't want to lose their data. Just think about a banking organization. Let's say that there's a data of banking organization hosted on a cloud, and because of some reason we lost the data. So do you think that any other organization will rely on that platform which loses the banking, such mission critical, such crucial data of customers? I don't think so, right? So here, high availability and disaster recovery is very, very important, and AWS work a lot in these things. Yeah. Make sure that your availability and security is maintained based on your compliance needs. Then we can talk about the scalability. Another very important aspect, as we have already discussed, whenever we need on-demand resources from cloud service provider, we should get it, and we should get it up to any scale. We don't know what is my need. Yeah. So ability to adjust the resources based on demand. So wherever I need more capacity, I should get it on the go, right? So that is one of the key advantages of AWS. Within few clicks, you can expand yourself up to no limits. Yeah. Then pay as you go pricing. It's all about budgets. There are different type of organizations. Some organizations have very high budgets on IT infrastructure. They have very large budget to spend on, but some organizations do not have such budgets. Maybe some mediocre or maybe some startup organizations, right? Then pay as you go pricing is a very interesting and important aspect when you have low budgets or maybe you have cost concerns. Every organization have their own capacity of expenditure. So here AWS provides the cost effective payment for services used. So based on your needs, based on your provisioning, based on your hired resources, you just have to pay. Don't worry about the other expenses, just pay for what you use. So AWS provide a lot of different services to monitor that cost, to monitor that usage and set some budgets on the base of which the infrastructure of AWS can be utilized. AWS supports a lot of such services which can help you out to manage your cost based on your provisioned and hired resources. Now here we will talk about the market share of other cloud service providers. So there are three major players in the industry. The first one, AWS itself, then Microsoft Azure, it's a product of Microsoft, and Google Cloud as the Google product, right? But you can just see here the market share of AWS is 32 to 33%. It is highest. So now you can just think about it. A lot of organization, or you can just think about 30 to 33% organizations, are actually relying on AWS for their applications and infrastructural needs. They have that faith, they have that reliability factor with AWS, right? That they have actually deployed their application, they have hosted their data on the top of AWS. So you can just see Azure has got 22 to 24% market share, and Google Cloud has got 9 to 10% market share. So this is all, and you will see here AWS is pioneer. It's actually covering 32 to 33% data. This number can change by the time. You can just see more share of AWS by the time, because AWS is working day and night to to consume the more customers, to serve more organizations like this. Now here we'll talk about the key drivers. As you have seen in the previous slide, that 32% approximately market share is with AWS. 1/3 of market is captured by AWS, you can see. But why? What are those things? Although we have seen the advantages, but what are those key drivers, right? Because of which business rely on AWS. Business really likes the AWS platform. These key drivers are enterprise use. So like ranging from a small scale enterprise going to a very large enterprise, AWS can host. So it's a whole spectrum of the range of enterprise which can be hosted by AWS. Key advantage, right? Then global infrastructure. We'll talk about the AWS global infrastructure in detail in the upcoming lessons. But here, because of the infrastructure which is globally accessible and globally spread, you can actually control the accessibility, you can control the deployments of the application, you can control the latency, which is actually observed by the customers which are far away from the application where it is hosted. AWS supports all those things for you. Then it is service portfolio. When you talk about service portfolio, it's a big range of services. I told you there are 200 plus services from which you can actually choose the service based on your needs. Like for an example, if I choose a server application where I need to maintain a server, or I can choose a serverless application where I don't need to maintain a server. I can directly go and use the service, that's it. So based on your choice, we have wide variety, whole catalog of services from which you can choose, and based on your business needs, you can go. Lastly, it's an ecosystem adoption. It's a very interesting thing. Just think about, you have already a legacy application running on premises. You are older company, you have already grown up, right? So you have your own setup, you have your own application, you have your backend system, everything is set, so set. So can this migration happen from on-premises to a cloud? That is what we call the ecosystem adoption. AWS supports the migration of those legacy platforms. Just think about it. Let's say you have a WordPress application and on the backend it is Oracle which is supporting. So here we have a solution in AWS that can support the WordPress application as well as the Oracle platform can be directly, Oracle databases can be directly migrated to AWS platform, and you can work as it is as we were working in on-premises, but with the ease, with the low cost, with the scaling capacity, with higher privacy and security requirements. So I hope you are getting the key drivers which makes it very popular among the different organizations when you talk about AWS. Yeah. That's it for this video. I hope you understood the idea behind AWS and its core key drivers which makes it very popular among the different organizations. That's it for this video. I will see you in the next video. Thank you.